Okay, so just a couple of things here before we get started. Make sure that you've read above the video here and take a look at those notes. There are a couple of things to keep in mind. First one, while you're watching these videos, and make sure you are watching these videos and doing the practice questions, make sure that you're checking your work and that you're reaching out if you have questions. It doesn't do you any good to sit there at home and have questions if you're not reaching out and asking about them, because I can certainly make another video if you have any questions, because there's a good chance that, if you would have asked in class, I could have stopped and addressed it, but I can't do that in a video. So if you have questions, write them down, make sure I don't answer them elsewhere in the video, and then definitely go ahead and send me an email, and I can help you out at whatever I can. So second thing is that starting probably this week and going forward, I am going to be taking 1 day per week as kind of like a standards review day. We're going to pick like one standard a week, review that, and that's going to give you a chance that if you wanted to retake that standard, you would be able to complete a review assignment after that day and then come in and do a retake over just that standard. Hopefully that gives you a more manageable way with everything that's going on to show me that you've got these standards, even if it's a couple weeks later or down the line, whatever that is. Okay, so let's go ahead and get started. I'm going to turn off my webcam here. Today we're talking about Unit 12, or starting Unit 12 on trigonometry. So trigonometry here is this triangle. Root word tri here is triangle. Metric is measure. So it's all about the measures of triangles, and specifically the relationships between the side lengths, the ratios of those side lengths. So today we're going to talk about those three ratios. They're called sine, cosine, and tangent. And we'll just get a start into using those ratios to solve for missing sides of triangles. Tomorrow will be all practice. So I'll probably put up a Khan Academy video or something for tomorrow that's a little bit more how to do this specifically, like straight to the point. So our vocabulary here is sine, cosine, and tangent. Those are the three words that you need to know the meaning of when we leave today. So here we go. First thing I did here when we started off in class is we took a look at this problem from, kind of looking like what we've done in the past. So in the past, we've had questions like this, and we've had to solve for the height of the tree. And the way we've done this is by using shadows. And so you would be standing next to the tree. You would measure your shadow, and you'd make a triangle out of it. And because the sun was in the same place for both you and the tree, we knew those triangles had to be similar. Now, pretty quickly, we're going to realize a problem here. Every time we want to use a triangle, we don't want to have to rely on the sun to find a similar triangle. So that was kind of annoying. So the next step here is, well, we don't have to always get our similar triangles from something occurring naturally in the problem. If we can figure out what the angle is and measure it, then any other triangle that has that same angle, even if we make it ourselves, is going to be similar. So these two triangles are similar to each other because of angle-angle. We got the 40s and we got the 90s. This lets us, even if we didn't have a triangle that's part of the problem, we could still solve it. And so here, maybe we would do something like this. We'd compare our sides, something like 2 over 30 equals 1.7 over x. And that would let us solve that problem. Now, same kind of deal there. We could also compare these in different ways. So what if I had said compared going this direction? What if I went with 1.7 over 2 equals x over 30? And if you go ahead and solve those two proportions, you're going to see that not only do we get the same answer, we actually get the same equation. 2 times x right there is 2x, and you'll get the same 2 times x there. 1.7 times 30 is 51. Same 1.7 times 30 there. So not only do you get the same answer, you actually get the same exact equation. And so either way we do that is fine. The way I circled in red there, that's the way most of you have been doing it with similar triangles. But the way that we're doing it in blue, comparing the two sides within this triangle to the two sides within this triangle, is the way we're going to do it in trigonometry. And keeping in mind here, the point of trigonometry and why we're doing this is we don't want to have that second triangle anymore. Our life would be a lot easier if we didn't need that second triangle. So that's what we're going for. Now, let's move on here. So in the past, what we've done is we've actually gone and we've made triangles like this. We've made an entire book of triangles from 5, 10, 15, 20, 25, 30, 35, 40, 45, all the way up to 85, 90 degrees. And we've drawn them all in a book. We've measured their sides, and we've used those as what we call reference triangles to solve for missing sides of a triangle. Now, that gives us a couple of big problems here. Number one being that we had to draw out 9 or 10 different triangles. It took up a lot of space, took a lot of time to do. Also wasn't super accurate. Second problem was we even only did every 5 degrees. So what happens if this is a 42-degree angle for some reason? Then we're out of luck. So the next step in this whole process was let's get rid of those triangles. All we really need are the side lengths, and we can write those down in just a list really fast. We don't need to have the whole triangle. And so that's the next step that people took in history, is they started to get rid of the triangles. And when you get rid of the triangles, you need to name the sides, because without naming the sides, you don't know what you're talking about. So in this triangle, we're always going to have our 90-degree angle. That's got to be there. Then we're going to have our reference angle. That might be called something like angle A. You might also see this weird little symbol in here that's circled. That is a theta. It is just a Greek letter, just like A is an English letter. So nothing special about that. That is the angle we're discussing or talking about in our triangle. It's usually going to be the only one you know. If you take that angle and you go straight across from it, that is going to be called the opposite leg. The longest side is always still called the hypotenuse. And then the leg right next to the angle, the one that's not the hypotenuse, is the adjacent leg. Adjacent just meaning next to or touching. And so we've got our 3 different triangle sides named. And so it's completely obvious, like we all know what we're talking about when we say opposite. Now, the last thing we're going to do before we kind of step into this is realize that we're never actually just using one of these sides. Just like over here, we're always taking a ratio or a comparison with division of one of the 2 of these sides. And so rather than writing down the side themselves, people decided that they should instead write down these ratios. And so these are the words that you just need to know these definitions. Sine is the opposite leg divided by the hypotenuse. You just literally divide those lengths, and that's what the sine is. Cosine is when you take the length of the adjacent leg and divide it by the length of the hypotenuse. And tangent is when you take the length of the opposite leg and divide it by the length of the adjacent leg. And so this goes together. What you're seeing on your screen right now is what you have to have memorized to be able to do trigonometry. You've got to know what those words mean so that when someone says cosine, you know it's adjacent and hypotenuse, and you know which sides are adjacent and hypotenuse. Now, a couple of things you can use to help remember what those sine, cosine, and tangents are. Most common you're going to see around here is going to be SOHCAHTOA. And the letters in that just stand for the ratios. The SOH is saying sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And one thing I've seen a few people doing today that I think is really nice is writing it out like this. It still gives you the same SOHCAHTOA, but it kind of writes it out where you've got the fractions ready to go for you. So that's kind of another nice way I saw that today. Next up, what we've got here is a little bit of practice. If you have this handout downloaded, it's there for you. If not, you can just do this on a separate sheet of paper. But probably one of the biggest mistakes I see right away is just identifying these sides incorrectly. So for this one, if I'm starting off with side A, or angle A, and I want to identify the opposite, I go straight across. There's my opposite. My hypotenuse is always the longest side, and my adjacent is the one that is touching the angle A. So go ahead and pause this video, fill out those other 2, and then start it up, and we'll go over those. Okay, so in these other 2, here the 5 is going to be the opposite, the 3 is the adjacent, and the hypotenuse is the 5.8. In this one, the 9 is the opposite, the 6 is the adjacent, and this is the hypotenuse. So hopefully those were pretty good. Now, the last step in this is identifying the ratios here. And so now we have the sides labeled. Let's go ahead and find the sine of A. We abbreviate sine, S-I-N. And so remember, sine is just opposite over hypotenuse, so it's 4 is the opposite over the hypotenuse, which is 9.8. For the cosine of A, we're taking the adjacent, which is 9, divided by the hypotenuse, which is 9.8. And for the tangent of A, we're taking the opposite, which is 4, divided by the adjacent, which is 9. Okay. Next up, I want you to try those other two and then pause the video, try those, and then come back and we'll go over them. Okay. So for these last ones here, the sine for A in this one is going to be 5 over 5.8. Cosine is 3 over 5.8. And the tangent is going to be 5 over 3. And then this last one, the sine is going to be 9 over 10.8. Cosine is 6 over 10.8. And tangent is going to be 9 over 6. Okay. So last thing I have as a question here is just, of those three, which one were we using up here? And you can look at this and say, well, I was using the opposite divided by the adjacent, x over 30. We were using the tangent on this one. And so that's our tangent. That's what we were using there. Now, from here, the next step in this whole evolution over history is we had to get rid of this triangle like we talked about. So in order to get rid of this triangle, what we did is we stopped drawing the picture of the triangle, and instead we started writing down the sine, cosine, and tangent for each of these angles. And so what you can see is rather than drawing a triangle with a 40-degree angle, people just recorded that the sine, in other words, the opposite divided by the hypotenuse is this, the adjacent divided by the hypotenuse is this, and the opposite divided by the adjacent is this one. And so these numbers could be used to solve any problem we want as long as the angle is a nice whole number. And so if I go back to my picture here, I'm going to go ahead and change this back to 40, because I think that's what it is on the sheet. We'll put an x over here, and let's talk about how to solve this. So with our chart, which has all the information we need, we're going to look at, first of all, which of the ratios we need. So that's the opposite side. That's the adjacent side. And so opposite and adjacent make tangent. So I'm going to look down my tangent list. Next up, I'm going to look at my angle, which is 40 degrees. And I'm going to go ahead and write my equation out. So in this case, I know that the tangent of 40 is equal to, in this triangle, it's x over 30. I'm setting that up just exactly like we set this up, just that we know the angle now and we don't know one of the sides. So same exact setup. Now, in order to actually figure out what x is, this is where the chart comes in. So I look at my tangent, I look up here to what my chart says. It says tangent of 40 is 0.8391. And so I'm just going to replace the tangent of 40 with 0.8391 equals x over 30. So this side, the left-hand side, is just taking the place of this triangle here, this 1.7 over 2. 1.7 over 2 equals x over 30. And instead of the 1.7 over 2, now I have tangent of 40, which I know that value. It's very, very close, actually, to 1.7 over 2 if you actually looked at it. So to solve this equation, I just need to take both sides of my equation and multiply by 30 to get the x by itself. So x equals 30 times 0.8391, which calculator says is 25.17. And there's my answer. Now, the last step in this whole deal is calculators were invented. No matter what calculator you're using, whether it's these scientific calculators or Desmos, please do not use your iPhone calculator for this. It is different. It works differently, and you're going to get into trouble when you try to take the test without your iPhone calculator. So these calculators have sine, cosine, and tangent right there and right there. On the Desmos calculator, they're just right on your screen. So when I have my calculator, I'm now able to take this triangle, and without the chart, I can still solve it. A calculator has all that information from the chart in it. So we've got the same exact picture there. I have the opposite side just like before. I have the adjacent side just like before. And so I know I'm using tangent. So tangent of 40, just like before, nothing's changed here, equals x over 30. One difference is I'm not going to replace that value of tangent 40 from my calculator just yet. When you use your calculator, you end up with like 8 or 9 or 10 decimal places. I don't want to deal with that. So I'm just going to go ahead and do the exact same steps. I'm going to multiply by 30. I'm going to multiply by 30. That's going to cancel that out. And so I get 30 times the tangent of 40 equals x. It's 4d, not 4. And then this is the part that I type right into my calculator, exactly as it's written, whether it's Desmos or your scientific calculator, but not your iPhone calculator because that doesn't work the same way. And my calculator says it's 25.17 equals x. And that makes sense. We got the exact same answer we got the last time because we rounded it off more, to less decimal points than either one of those things have. Your calculator can give you more decimals, but we're not going to use them anyway. So that's basically how you're going to set every single one of these up. You're going to pick your sine, cosine, or tangent, put your angle in, equals your ratio from your triangle. You're going to solve for x and then punch it in your calculator. And I've got the steps written right there. If you've got the handout, they are printed right in it. And for now, starting off, I do want you to do all of those steps. I want you to mark the angle, label the sides, pick a trig function, write the equation, solve the equation, and then put it in your calculator. I want that all written on your paper because that's how we're going to help with figuring out what we need to work on if you're not getting some of these. So the last thing here is the practice questions. If you download the handout, which is right below the video link, you have access to these practice problems, and you'll notice that at the end of these practice problems, there are answers. So make sure you're checking your work. I do want to go over this first one together because it's just a little bit different than the last one we did. So we take a look here. This one is the hypotenuse. This one is the adjacent. Hypotenuse and adjacent, or adjacent over hypotenuse, is cosine. So I'm going to write cosine of 15 equals 7 over x because it's adjacent over hypotenuse. Now this one looks a little bit weird. You've got that x in the denominator, and that's an equation that you haven't done a lot with before in algebra. So the way I like to handle this is I will think of this as a proportion. I write this cosine of 15 over 1, and then I can go through and just cross multiply. X times cosine of 15 is, well, x times cosine of 15. Can't do anything with that. 7 times 1 is 7. And now, if I want to get rid of this times cosine of 15, because I remember I just want to keep the x there, I can divide by cosine of 15 on both sides because it is just a number. If you remember back to that chart, it's just a number that your calculator is looking up, and I can cancel that out, and I have the equation x equals 7 divided by cosine of 15. And that is something that I can type directly into my calculator and see what I get. So calculator says 7 divided by cosine of 15 is 7.24 or 7.25 if we round correctly. And there's your answer. So go ahead and give those a shot. Tomorrow I'm going to post a video with a slightly different way of talking about this, probably from either Khan Academy or some different YouTube video. And along with some more practice with the answers available to you. So you'll have that ability to check your answers as you go. Make sure that if you are missing some of these questions that you are asking about them because that is the only way you get better at these. And then other than that, hopefully I'll see you back soon. And have a good night.